Hello, viewers, welcome. Let's have another episode on linear programming. So, in this episode, we want to have the introduction to the topic linear programming. We know linear programming is made up of two separate words, linear and programming. So, when they take linear, it's only showing a relationship between multiple variables, and those variables are of the degree 1, meaning we don't have quadratic, cubic, or quartic, just a degree of 1. Those variables, which are the constraints, has a variable of a power of 1. Then when you take the programming, it's just a way of selecting possible solutions that is best. If you are selecting possible solutions that are from a lot of constraints, various possible solutions, you are selecting the best that fit for your criteria. That is what we call linear programming. Bringing it into mathematics just to get mathematical understanding, we can say that it is the method of considering difference in inequalities, with those constraints could either be inequalities or equalities, relevant to a situation, and calculating the best value that is required to be obtained in those conditions. So basically, you'll be provided with a lot of constraints, that is a lot of hindrances, from which you choose is a way of optimizing or minimizing or maximizing either profit or benefit. So basically, this can be used in economics, economy, that is what economics, or by the economist, used in telecommunication, whereby we are presented with possible variables, with constraints, which we have to select the best situation that fits in that scenario. In the business administration, maximizing a profit, how to maximize a profit. What will you do in order to maximize profit when you are provided with materials and personnel? What will you do in order to minimize loss? All those things are about linear programming. But because we are making use of the constraints, which are basically inequalities, so we will begin with the introduction into inequalities. The inequalities also compares two algebraic expressions with inequality sign or inequality symbols. So we can say any statement that expresses the inequality between two algebraic expressions, we call it what? The inequalities. So what are some of the symbols that are used in describing inequalities? So we can say we have our symbols, then what are their meaning? We can have this as in less than. Then we have this as in greater than. We have this or this, that is less than or equal to. Then we have this also as greater than or equal to. So these are the four inequality symbols that are placed between two algebraic expressions, which are showing inequality. There's no equality, or in terms of equilibrium. So we can say that if we are using these symbols, making use of, let's say, A less than B, this is true only if A is found at the left side of B on the number line. If you have A found on the left side of B on the number line, simply put, if I have 4 less than 7, this is true only if on the number line 4 is found at the left side of 7. Or better still, 7 is found at the right side of 4 on the number line. Let's just say we have 0, so -1, not in interval. So let's say 4, 5, 6, you have 7. You can see that 4 is at the left of 7. So 4 is less than 7. Then 7 is also at the right of 4. So you can say 7 is also greater than 4 in that scenario. So if 7 is greater than 4, it means that the 4 is also less than 7. So these are the inequality symbols that will be used in order to describe inequalities. Now, if we are describing the inequalities, we can also have them in terms of intervals. So how do we also put these in intervals? Let's see how we can do that. So talking of the intervals, we are going to get all our values that we are going to get in terms of calculation are all going to be real numbers. So all the intervals are going to be subsets of a real number, a set of real numbers. So you can say that the following, the first one we are going to deal with will be A to B, which is given as set of x such that, okay, let's say x belongs to a real number such that we have A is less or equals to x, less or equals to B. So this is a subset of a set of real numbers, meaning if we are seeing this kind of bracket, which is the closed bracket, this one is showing that the element that we are having here is part of the interval. So from A to B, x is only referring to the element, the intervals or the element of the interval. The set that we are referring to is from A to B when we make use of this bracket. Now, in the case where we make use of this bracket as a curve, we have it as x belonging to the set of real numbers such that A is less than x less than what? B. So now you see the difference here, that this bracket shows that the element, the end point of the element are not part of the interval. So if I have 1 less than x less than 7, it means 1 and 7 are not in this interval. Then we can also have situation where I have this A, B, so that will be x belonging to this such that we have A is less or equals to x less than B. I believe by now you can be able to decipher the meaning of this, being close with this. This is being part of it. So the A is part of the set of the intervals, while B is not part. So if I have 4, 7, it means the interval will be 4, 5, 6. 7 will not be part of those intervals. Then likewise, if I have A, B, this will also be a set of x where x belongs to real numbers. We have our A less than x less or equals to B. In this case also, we are saying that A is not part of the element of the set, the interval, while B is part. We can see the inclusive. Then let's see number 5, a situation whereby we have so we are moving from negative. No, it's an interval. So here and here. So from our left side, we are moving from any number you can imagine. Infinity. There are a lot of negative numbers that we cannot write. We cannot be able to give quantity to. We can't quantify it. So it means that we cannot be able to list all the elements going to the left. But we can be able to list up to A. So between infinity and A, between. So it means that A is going to be the greatest of all the elements you are going to see. So if you are going to use x X is going to contain all numbers less than A, or A is going to be bigger than all numbers of X. So I can say that X is less than what? A. The values of X belonging to the set of real numbers such that X is less than A, meaning all those values that we can imagine are less than A. So we can write this. Or you can also write it in the sense that A is greater than what? X. Meaning A is bigger than all other numbers. Don't think that because it is an infinity, we have a very big numbers that we can't mention from there, they are all negative. So a negative will always be bigger than what? A positive. Even if A is a negative 4, all the numbers to the left of a number is less than the one at the right. So definitely negative 4 will become bigger than the values of X. Alright, I believe you catch that explanation. So we can also have negative infinity, A close bound, which we have set of X belonging to this. So what are we going to do? It is the same explanation, so that in this case A is going to be part of the interval. It is not going to be between the infinity and A, but rather it is from infinity to A. So I can write this as X greater, no, X will be less. So X is less or equals to A. That is the interval we can be able to give to that. Then let's see the case whereby we can also have A, then we have infinity. A to infinity. This is infinity mean positive. Large positive numbers to the right of any number. So we can also have that X belonging to R. So that in this case on the left, we are going to be between A to infinity. So in this case, A is going to be the smallest of all the numbers we are going to give in the interval. So if I put 7 here, the numbers to the right will be 8, 9, 10, 11. So all those numbers are greater than A. And all those numbers represent X. So X will be greater than what? A. Believe you get it. Good. In other way, we can also say A is less than what? X in the same vein. Alright, let's see number 8, whereby we can have this. I believe at this point you know what to do. With the symbols we are having means that X is greater or equals to A. Then let's take the last one. So in this case, we are saying that to the left, a large negative numbers, to the right, a large numbers. So where do we start from? So in order to represent this, any number you mention, you think of, you imagine, is part of the set. So we can say that this set belongs to real numbers, or I will just say X belongs to the set of real numbers. So all numbers you will mention will be in that interval. Alright, so these are the subset of the real numbers we can be able to get in terms of interval. We can also make note that all these are not the same. So the intervals. So the interval that we are having, the interval in this form, which is A, B, this interval, A, B, take note of the bracket, this interval, A, B, this interval, A, B, are called so this type of interval is called what? Or are called bounded. Why are they bounded? Boundary. It means there is a boundary we can be able to know, put a boundary at the beginning and at the end. Here, even though we know A is part, B is part, so we know that all the elements are bounded. Here, A and B are not part, but it is serving as a boundary for us, that the numbers between A and B is what we're looking for. So there is a boundary around that. Then here, A is part, B is not part, but you know the boundary, that don't cross this line. Here, you can play up to this place, but when they get to that side, don't play up to the wall. But you know there is a boundary. There is no free range. So these four are called bounded. Then, so the rest of the interval that are in this form, we have negative infinity, A, negative infinity, A, infinity. We can have A infinity and negative infinity and infinity. These ones are also called unbounded. It means one endpoint is not known. At least one of the endpoints is not known. Here, you can't tell the endpoint. You can tell the boundary here that move towards A, don't get to A. That's the boundary. But here, you can go up to any length. So it is not bounded. So unbounded. Here, unbounded. Unbounded. Here and here. So these ones are also called unbounded. So we can also find out from here that the intervals, that there are some that are called close. If they are close, it means that at least one of the endpoints is part of the interval. One of the endpoints. So if I am looking here, the A is part of the interval, B is part, so at least one, and here 2. So we can say that this is 1. Here, none of the endpoints are part of the interval. Here, the A is part. If we come here, A is not part, but B is part. Which one again? I think this. Okay, if we come here, we can be able to state that A is part, but we don't know the other endpoint. Here also, we can tell that we don't know the beginning, but we know this are called open interval. Then the final one will be so the remaining ones that are not open, no, I think this is close. The one that we mentioned first is close. So this is close interval. Then the remaining ones are going to be open. Open in such a way that the interval, the endpoint, are not part of the interval. So you can see this and this. The endpoint are not part of the interval. So this is going to be open. It is open. So we can be able to state the ones that are open from here. This A and B are not part of the interval. Then here one is part, one is part. Here none is part. So we have negative and A. If you come here, A is part. Here, A is not part. The infinity is not part. Then we have negative infinity and positive infinity. So these are called open interval. So these are the interval rates or the various interval definitions we can take, which are the constraints that we are talking about. Do we presented with a lot of constraints in form of inequality? Then we will be using this inequality to maximize or optimize, either showing the maximum or the minimum value we can be able to get. In the next episode, we will deal with how we can represent these intervals on a number line when we found them in an inequality question. Don't miss the next episode. Share this video, like, and comment. Bye bye.